The rotor blade was cracked from tip to root, a jagged line running 26 feet along the forward starboard blade of a CH-47A sitting in red mud at a forward operating base near Pleiku. CW2. Jim Gruenwald stared at it in November 1965 and did the math. A replacement blade weighed over 200 pounds. The only helicopter that could carry the blade, the maintenance crew, and the rigging equipment to swap it out in the field was another CH-47. So a Chinook had to rescue a Chinook. The Army's newest, biggest helicopter had been in Vietnam for roughly 10 weeks, and it was already talking to itself. Gruenwald flew with the 147th Assault Support Helicopter Company, one of the first Chinook units deployed to Southeast Asia, arriving in country in August 1965. The men who flew Hueys called the CH-47 the slow, fat target. Gruenwald's unit heard it constantly. The nickname stuck because it described something real. The Chinook cruised at 130 knots on a good day, stood nearly 19 feet tall, and presented a fuselage profile roughly the size of a Greyhound bus. In a war defined by small, agile UH-1 Hueys darting between tree lines, the Chinook looked like it had wandered in from the wrong conflict. Army aviation doctrine in 1965 didn't quite know what to do with the thing. The original requirement, born from a 1956 Department of the Army specification, called for an all-weather medium transport helicopter that could haul troops, cargo, or weapons across a mid-intensity European battlefield. Flat terrain, short distances, organized logistics chains, predictable threat envelopes. Vietnam was none of those things. The airframe was wide enough to swallow a Jeep whole. Its twin Lycoming T-55-L-7 engines produced 2,650 shaft horsepower each, and the tandem rotor system, counter-rotating, no tail rotor needed, gave it a maximum payload capacity of roughly 15,000 pounds externally. Internal cargo space ran 30 feet long. The empty weight alone topped 20,000 pounds. Every one of those numbers made conventional helicopter pilots nervous. Bigger meant slower, and slower meant you sat in somebody's gun sight long enough for him to finish his cigarette. The Huey community had a saying that went around fire bases faster than malaria. If you can't be fast, don't be big. The 1st Cavalry Division's leadership was skeptical enough that early operational plans kept Chinooks in rear areas, hauling supplies between established bases. Boring, safe work, exactly the kind of mission that justified calling the aircraft a flying truck and leaving it at that. The Chinook might have stayed a flying truck too, except the jungle started eating helicopters at a rate nobody had predicted. Philadelphia, 1958. Inside the Vertol Aircraft Corporation plant on the edge of the city's northeast industrial corridor, engineer Frank Piasecki's successor team was already building the airframe that would become the CH-47. Vertol had won the Army contract with the Model 114, a tandem rotor design that owed its DNA directly to Piasecki's earlier H-21 Flying Banana, the ungainly workhorse that had carried French troops in Algeria and American advisors in the earliest days of Vietnam. Boeing absorbed Vertol in 1960, and the Model 114 became the Boeing Vertol CH-47A Chinook. First flight came on September 21, 1961, at the company's test facility outside Philadelphia. The smell of hydraulic fluid and turbine exhaust hung over the tarmac as the prototype lifted off, nose slightly high. The twin rotors biting air with a distinctive overlapping thrum that no single-rotor helicopter could replicate. The Army accepted its first production Chinook in August 1962. Fort Rucker, Alabama, became the schoolhouse. Pilots transitioning from the H-34 or UH-1 reported that flying the CH-47 felt less like piloting a helicopter and more like steering a building through a parking lot. The controls were responsive enough, but everything happened on a larger, slower scale. The tandem rotor configuration eliminated the power-robbing tail rotor entirely, which meant more of the engine output went directly into lift. It also meant crosswind handling felt fundamentally alien to anyone trained on conventional designs. By mid-1965, Boeing Vertol had delivered 161 airframes at a unit cost of approximately $650,000 each, roughly 4 times the price of a Huey. Pentagon accountants noticed, so did congressional staffers. The question kept surfacing in procurement hearings: why spend this much on a cargo helicopter when the smaller, cheaper UH-1 fleet could theoretically distribute the same tonnage across more sorties? The arithmetic made sense on paper. Paper, however, had never tried to resupply a fire support base cut into a ridgeline at 4,000 feet during monsoon season, with 800-foot ceilings and a single landing zone the size of a tennis court. How many helicopters does a war eat? In 1966, the answer was more than anyone in the Pentagon had budgeted for. The Army lost 207 helicopters in Vietnam that year alone, to ground fire, mechanical failure, weather, pilot error, mid-air collisions, mortar attacks on landing zones. By 1967, the number climbed to 318. By 1968, the worst year, it reached 543. Across the entire conflict, the United States would lose 5,086 helicopters in Southeast Asia. That figure comes from the Army's own records, compiled post-war and published by the Center of Military History. But lost is a misleading word. A helicopter that crashes in a rice paddy isn't necessarily destroyed. The engine might be salvageable. Its transmission, worth tens of thousands of dollars, might be intact. And then there were the weapons systems, radios, classified encryption gear, all of it sitting in hostile territory, waiting to be captured or studied. The Army's standing policy was unambiguous: recover or destroy. You did not leave American military hardware for the enemy. The problem was weight. A downed UH-1 Huey weighed roughly 5,200 pounds empty. A damaged CH-34 came in around 7,900. An OV-1 Mohawk surveillance aircraft, which kept crashing in places no truck could reach, weighed over 9,000 pounds. The only helicopter in the Army inventory with the external lift capacity to snatch these airframes off jungle floors, flooded paddies, mountainsides, and bomb-cratered clearings was the CH-47. General Hamilton Howze, whose 1962 Howze Board report had essentially invented the concept of Army Airmobility, wrote in a later assessment that the board never adequately addressed the problem of battlefield recovery at the scale Vietnam demanded. The Howze Board had envisioned losing helicopters at European theater rates, a handful per month in a conventional fight. Vietnam was producing damaged or destroyed airframes at a rate of roughly 14 per week by 1968. 14 per week. Every single one needed to be pulled out, slung under something with enough power to haul it, and flown to a maintenance depot or a destruction point. The Chinook crews, who had been hauling water trailers and ammunition pallets between rear area bases, were about to get very busy. 0430 hours, Bien Hoa Air Base. Dry season, 1967. The mission brief lasted 8 minutes. A UH-1D from the 118th Assault Helicopter Company had gone down in triple-canopy jungle, 14 kilometers northwest of Xuan Loc. Tail boom, sheared off by trees during an emergency auto-rotation. Both pilots survived. The airframe sat largely intact in a gap between mahogany trunks, and MACV wanted it back before the NVA stripped it. The recovery crew from the 228th Assault Support Helicopter Battalion had 2 hours of usable morning light before thermals and afternoon thunderstorms would make the hover and extract impossible. Nobody had written a manual for this. The CH-47 flight manual covered cargo sling operations over prepared landing zones, flat ground, clear approaches, known weights. Pulling a crumpled Huey out of a jungle hole where the rotor disc barely cleared the canopy on 2 sides required a completely different skill set, and the crews who developed it did so through repetition and accumulated bruises. CW3. Robert Mitchell, a Chinook pilot with the 228th, described the process in a 1992 interview with the Vietnam Helicopter Pilots Association. "We wrote the procedures by doing them wrong first and surviving." The technique that emerged was called a vertical extraction, though the crews themselves used less formal language. The Chinook would orbit the crash site at altitude, while a Pathfinder team on the ground rigged the downed aircraft with sling cables, typically a 4-point harness attached to the strongest structural points on the airframe. Rigging a Huey took a trained crew 20 to 40 minutes, depending on damage and terrain. The Chinook would then descend vertically through whatever opening existed, hover with 0 forward airspeed, while the ground crew attached the hook, and climb straight out under load. Each phase of that sequence could kill you differently. The vertical descent put the Chinook's belly at treetop level in a hover. Fat, loud, stationary, completely defenseless, burning fuel at maximum rate. Ground fire during the hookup phase meant the pilot had two choices: drop the load and climb, or take the hits and keep hovering. Flight engineers learned to read the jungle canopy like a weather forecast, judging rotor clearance by the way leaves moved in the downwash. The fuel math was punishing. A CH-47A at maximum gross weight burned approximately 400 gallons per hour. A typical recovery mission consumed 90 minutes of flight time each way. That left a working window over the crash site of roughly 15 to 20 minutes before the crew had to abandon the attempt or risk flaming out on the return leg. 15 minutes to save $650,000 worth of helicopter. The 228th ASHB flew more aircraft recovery missions than any other Chinook unit in Vietnam, and the single sortie that best captures what those crews faced happened on March 30th, 1967, in Binh Duong Province, 40 kilometers north of Saigon, in country the Army had already swept twice that month and that the Viet Cong kept reoccupying like tenants who'd lost the eviction paperwork. A UH-1D from the 187th Assault Helicopter Company had taken a .50 caliber round through its engine compartment during a combat assault into LZ Orange, an unimproved clearing bordered by tree lines on three sides. The Huey auto-rotated hard, skids buckling on impact, but the crew got out. A rifle platoon from the 1st Infantry Division secured a 60-meter perimeter. The call went to the 228th at Bien Hoa. Recover the airframe before dark. CW2. Dennis Trimble lifted his CH-47A off at 14:35 hours with a 4-man crew and 2 Cobra gunships riding escort. Flight time to LZ Orange was 22 minutes. The Cobras made 2 gun runs on the eastern tree line before Trimble began his approach. Minigun fire chewing through bamboo and secondary growth spent brass cases raining into the canopy below. At 15:01 hours, Trimble brought the Chinook into a high hover over the clearing. 40 feet down, the rigging team had already attached a 4-point sling harness to the Huey's main structural hardpoints. The flight engineer, SP5 Gerald Kowalski, talked Trimble down foot by foot through the belly hatch, calling corrections in a voice that the aircraft commander later described as completely bored, like he was parking a car at the PX. Trimble recounted the mission in a written account submitted to the 1st Aviation Brigade's after-action files, now held at the National Archives. At 30 feet above the downed Huey, small arms fire opened from the southern tree line. Rounds punched through the Chinook's lower fuselage skin, 7.62 millimeters, audible even over the rotor noise as sharp metallic pops. Trimble held the hover. Kowalski kept counting altitude. 20 feet, 15, hook contact. The load came taut, and the Chinook sagged, nose dipping as 5,200 pounds of dead Huey transferred onto the cargo hook. Trimble pulled collective, and the CH-47 climbed through translational lift at a rate that felt glacial, 200 feet per minute with the slung load swinging beneath. More rounds hit the aft pylon fairing. Hydraulic fluid began misting from a line somewhere behind the cockpit, 7 minutes from hookup to clearing the tree line. The Cobras expended their remaining ordnance covering the departure. Trimble landed the Huey at Lai K Maintenance Depot at 15:38 hours, 63 minutes after takeoff. Post-flight inspection counted 11 bullet holes in his Chinook. Maintenance had it flyable again in 2 days. The recovered Huey took a week. Both aircraft returned to service. Combined, they represented roughly $800,000 in airframes kept out of enemy hands. The repair bill amounted to aluminum skin patches, a hydraulic line, and 2 days of maintenance crew labor. The smell inside a Chinook after a recovery mission was hydraulic fluid, jet exhaust, dust off the LZ floor, and the metallic tang of fresh bullet holes letting outside air whistle through the fuselage. Every crew knew it. By 1969, most of them had stopped noticing. Trimble's sortie was one mission on one afternoon in one province. Multiply it across 8 years, 4 core tactical zones, and 22 Chinook companies rotating through Vietnam on 12-month deployments, and the arithmetic becomes staggering. The 1st Aviation Brigade's operational summaries, compiled quarterly and now declassified, record that CH-47 units recovered approximately 11,500 disabled aircraft during the course of the war. The estimated replacement value of those airframes exceeded $3.5 billion in 1970 dollars. Adjusted for inflation, that figure approaches $26 billion today, more than the entire annual procurement budget for Army aviation in most recent fiscal years. 11,500 aircraft. Sit with that number long enough and you start to feel what it demanded from the Chinooks themselves. Each recovery sortie meant a hover at maximum gross weight in unprepared terrain, often under fire, always at the outer edge of the performance envelope. The CH-47A's T-55-L-7C engines were rated at 2,650 shaft horsepower each, and recovery pilots routinely pulled every available watt. Overtorque inspections, the maintenance procedure required after a pilot exceeds the transmission's rated limits, became so common in recovery-heavy units that crew chiefs started pre-positioning the inspection paperwork before the aircraft launched. SP6 Wayne Delacruz, a technical inspector with the 242nd Assault Support Helicopter Company, told the Army Aviation Heritage Foundation in 2004, "We stopped being surprised by overtorques. We'd have been surprised by a recovery bird that came back without one." The cost savings were real, but the strategic math ran deeper than dollar signs. Every Huey dragged out of a rice paddy was a Huey the NVA couldn't photograph, disassemble, or ship to Soviet technical intelligence teams in Hanoi. A recovered avionics suite meant frequencies and encryption architectures kept out of hostile hands. A 1971 MACV intelligence assessment noted that captured American helicopter components had appeared in Chinese technical publications as early as 1968. Partial schematics of the T-53 turboshaft engine, descriptions of the AN/ARC-131 radio system. Recovery missions were plugging an intelligence hemorrhage, and the money saved was almost secondary. And the Chinook crews paid for it. The 228th ASHB alone lost 12 CH-47s during the war, 4 to ground fire during recovery operations specifically. Across all Chinook units, 142 crew members were killed in action in Vietnam. The aircraft that commanders had dismissed as too big, too slow, too visible, too fat a target had become the most indispensable logistics platform in theater. Not because anyone planned it that way, the cargo hook that hauled dead Hueys out of the jungle could also deposit a 105mm M102 howitzer onto a mountaintop fire support base in a single pass. Gun, ammunition, crew, and sandbags, all in under 4 minutes. Recovery missions built the Chinook's reputation, but the rest of the CH-47's war mattered more. The troop lift numbers alone reshaped tactical planning. A single CH-47A carried 33 combat-loaded infantrymen. A Huey carried 8. To insert a full rifle company of 120 soldiers, a commander needed 15 Hueys flying in a formation that stretched across a kilometer of sky, each one a separate target. 4 Chinooks did the same job. Fewer aircraft meant tighter landing windows and less exposure time over the LZ. It also meant fewer radio calls cluttering the command frequency during the most vulnerable phase of an air assault. The 1st Cavalry Division's after-action report from Operation Pershing in 1967 noted that CH-47 company lifts reduced LZ exposure time by an average of 40% compared to equivalent UH-1 formations. Artillery placement was where the Chinook became irreplaceable. The M102 howitzer weighed 3,300 pounds. The older M101A1 came in at 4,980. Neither could reach a ridgeline fire support base by road, because the roads either didn't exist or belonged to the enemy after dark. CH-47s slung these guns onto hilltops across the Central Highlands throughout 1966 and 1967, sometimes repositioning the same battery 2 or 3 times in a week as the tactical situation shifted. One firebase exists for 72 hours, supports an infantry sweep. Then the guns get picked up and dropped somewhere else. Mobile artillery, made possible entirely by a helicopter, the brass had considered too cumbersome for the theater. Then somebody decided to bolt guns onto the Chinook itself. The CH-47A, nicknamed Go-Go Bird by its crews and guns a-go-go in official unit parlance, was a frankly absurd modification. A 21,000-pound helicopter fitted with a nose turret housing twin M24A 120mm cannons, an M540mm grenade launcher, 2 M187.62mm minigun pods, and up to 5.50 caliber machine guns in various door and window mounts. Boeing's Vertol division built 4 of them, only 4. The 1st Cavalry Division's 228th ASHB operated them in combat starting in mid-1966, and the results were mixed in the way that a flamethrower in a phone booth produces mixed results: devastating firepower, alarming vulnerability. 3 of the 4 were destroyed in combat within 18 months. The surviving ACH-47A, serial number 64-13149, took so much battle damage during its service life that maintenance records show it consumed replacement parts equivalent to 1.5 complete airframes. 462 CH-47s served in Vietnam. The Army lost 168 of them, a 36% attrition rate that would have killed any other program. Instead, Boeing kept building Chinooks. The B model arrived in 1967 with uprated T55-L-7C engines producing 2,850 shaft horsepower each. The C model followed in 1968 with redesigned rotor blades and a bump to 3,750 horsepower per engine. By the time Saigon fell in April 1975, the Chinook had already outlived every argument against it. The D model, fielded in 1982, was essentially a new helicopter, wearing the same silhouette. Composite rotor blades replaced the old aluminum ones. A triple hook cargo system allowed loads on the forward, aft, and center hooks simultaneously. The T55-L-712 engines pushed output to 3,750 shaft horsepower each, and the airframe's maximum gross weight climbed to 50,000 pounds, nearly double the original A model's combat weight in Vietnam. During Operation Desert Storm in 1991, CH-47Ds hauled fuel bladders, artillery, ammunition, and water across hundreds of kilometers of open desert to sustain the 18th Airborne Corps' left hook into Iraq. The 101st Airborne Division's deep attack on forward operating base Cobra, the largest air assault in military history at that point, depended on Chinooks to establish the fuel and ammunition cache that kept the AH-64 Apaches flying. Afghanistan broke helicopters the way Vietnam had, only at altitude. Bagram sits at 4,895 feet. The operating bases scattered through the Kunar and Pech valleys pushed above 6,000, and observation posts in the Hindu Kush exceeded 9,000. Thin air murders rotor performance. The CH-47D could still reach those outposts when Black Hawks couldn't. And the MH-47G, the Special Operations variant operated by the 160th SOAR, could do it blacked out, on night vision, in weather that grounded everything else flying, and land on a postage stamp of a landing zone. On May 2, 2011, 2 MH-47Gs sat on a forward staging base in Jalalabad as the backup insertion platform for Operation Neptune Spear, the raid that killed Osama bin Laden. When one of the 2 primary MH-60 Blackhawks crashed inside the Abbottabad compound, the MH-47G launched. Admiral William McRaven later told the Senate Armed Services Committee that contingency planning had always assumed the Chinook might be needed. As journalist Mark Bowden reported in The Finish, McRaven's team had designated the Chinooks as the extraction failsafe from the beginning of mission planning. The helicopter the Army once considered too big flew into the most sensitive special operations raid in a generation because, when the plan fell apart, the only aircraft with the range, payload, crew capacity, and fuel reserves to fix it was a Chinook. The CH-47F Block II will fly until 2060. Boeing delivered the first production model to the Army in 2023, and the math is straightforward. When the last one rolls off the line and serves its full operational life, Chinooks will have been in continuous U.S. military service for nearly a century. One airframe design, spanning from Kennedy to whatever administration occupies the White House in the 2050s. The Block II isn't a cosmetic refresh. New composite fuselage structures reduce weight by over 2,000 pounds while increasing structural fatigue life. The redesigned drivetrain handles 7,500 shaft horsepower, nearly triple what CW2 Jim Gruenwald's CH-47A produced when he stared at that cracked rotor blade in the mud at Pleiku. Advanced Chinook rotor blades, swept at the tips, generate more lift in thinner air, which means the altitude problem that plagued operations in the Hindu Kush becomes manageable rather than lethal. Maximum gross weight climbs to 54,000 pounds. The price tag runs approximately $38.5 million per airframe, and the Army's current program of record calls for 466 of them. Congress has not blinked at the $17.9 billion total acquisition cost, which tells you something about how far institutional opinion has traveled since 1965. 16 nations operate Chinooks today. The Royal Air Force flies them. So do the armed forces of Australia, Canada, Japan, South Korea, the Netherlands, Italy, and 8 others. When the RAF needed to resupply forward operating bases in Helmand Province, they used Chinooks, not because the British lacked alternatives, but because nothing else in their inventory could carry 10 tons of cargo into a hot landing zone at elevation and fly back out. The operational logic was the same one that sent the 228th ASHB on recovery missions in Binh Duong Province in 1967. 42 years later, it was driving British logistics planning in Helmand. The problem set hadn't changed, and the helicopter that solved it still looked the same from the ground. Boeing's production line in Ridley Park, Pennsylvania, sits 14 miles from the old Vertal plant, where Frank Piasecki's successor team first drew up the tandem rotor heavy lift concept in 1958. Workers there are building an aircraft whose fundamental configuration, 2 rotors, 1 cabin, rear loading ramp, external cargo hooks, has not been redesigned since Eisenhower's second term. The fuselage is stronger. The engines produce 3 times the power. The avionics would be unrecognizable to a Vietnam-era crew chief. The rotor system tolerates abuse that would have shaken an A model apart. But the answer to the question, how do you move heavy things to bad places in hostile conditions, remains a 98-foot helicopter with 2 rotors spinning in opposite directions. In November 1965, the Army's internal assessment called the CH-47 an oversized target of questionable tactical utility in the Southeast Asian theater. The current program of record funds it through 2060.